to Engineer's Workshop. So I guess we'll continue with the All About Grinding series since we're working on the Cincinnati tool and cutter grinder. I'm going to go ahead and continue with removing the auxiliary table, lifting off the main rolling table after unscrewing the rack, and proceeding with shimming to make this more level with the front and back travel. But before we do that, let me show you a real quick update on the Do More tool and cutter grinder and what I found out about the belt for that item over here. So we'll do that first, and we'll come back here and continue on the tool and cutter grinder. So this is a factory belt from Do More, and with the 1 and the 3 pulley, it works. But the thing that I was having problem with was when I went to put the number 4 pulley on. And with the number 4 pulley, this is with the motor all the way up against its stop, and that belt is too short. So I ended up getting from McMaster, this is a McMaster flat belt. This thing does have an arrow on it, but in putting the flat belt on from McMaster, everything appeared to be pretty good. So I'm going to go ahead and show you how that works. Fire in the hole. So all's well with the world with that setup. And the nice thing about this is for the other shiv combinations, like if you run the internal grinding burrs, you actually swap these. So the center to center length is the same. But for a 3-inch, for the number 1 and the number 3, it's not 3 inches. That combination also works with the McMaster 21-inch belt, and I'm not going to turn this on because the grinding wheel I have on here is not rated for this speed combination. But that's the shortest, or rather the longest center-to-center distance that I would have with the pulleys. And let me show you over here, and you can see that there's still more travel where the motor would pull back further, and that belt would end up working for, you know, even smaller pulleys, different combinations. So glad I have that, and I have the factory Do More belt for pulley combinations that would warrant it. But for the bigger grinding wheels right now, I'm going to leave this guy on and try out my 4-inch grinding wheel on another workpiece in an upcoming video. Something I didn't mention in the last video, the oil recommendation for this spindle is a very light-bodied oil, spindle oil, ISO VG10, and I set up one of my vintage oil cans with that oil, and it just it just pours out of here. But the 2 oil cups are on this side to oil the spindle bearings. So I put a little bit in those oil cups every time I run this. When I set this thing down with the pallet jack, I did not get it exactly centered under my beam, so I need to get the center of gravity of the table even with that chain so that I can use the overhead hoist to lift it. I need to just make a very small adjustment to the position of this. And basically what I'm doing is I'm trying to keep the rack centered between the table here. Just a hair more. And it is close enough. From what I can tell, the table is a little bit asymmetrical. I mean, I know that the center line distance from the pivot to this end of the table is longer than from the pivot to this end of the table. And the machine section corresponds with that also. But if you look at the travel of the machine, this is what I would call the neutral center, because the rack is extending out, a fixed amount on both sides. And when the rack moves and the rack ends here, which is where the hand wheel adjustments are, they actually run off the end of travel. Now, a lot of times, you're just running this thing back and forth by hand. But if we run across here until the table stops, there's a stop. And basically what's happening is the ball cages are hitting up against a cap screw that's sticking up at the end of the V-ways. So I've slid that over, and I'm going to now roll over to the other limit of travel. And there again is the stop. So if I slide that there and we measure that distance, so what's left between the stop post is 19¼ inches. That's the effective travel of the table before the ball cages run against their stops. And now you can see that I'm turning this wheel, but this rack has run past the end of travel. And I have to get back to here for it to re-engage, so about 2 inches in. And from that point I can run it with the hand wheel. Now I can force it farther, and as I go farther, the ball cages are bottomed out against those cap screws and the table's actually sliding on the balls. But now I've effectively shifted the neutral center, and now you can see I can't go quite as far from that. So if I close that up, there's my 19¼ inches of travel. So I guess you can play with it to accommodate different workplaces. What I want to do though is get it centered about here, remove the auxiliary table, and then lift the main table off of the 2 ball races. There are 5 3/8 cap screws along the center line holding the rack to the underside of the table, and driven in from above is this massive taper pin. I mean, that's like about a 7/16, 3/8 to 7/16 diameter taper pin reaching all the way through that casting and screwing into the rack. I was able to drive the just take a dowel from the underside, tap upwards, and remove that. But yeah, those are the cap screws holding the rack to the underside of the table. So now, as I remove these, it's packed with grinding residue in here around the heads. Anyway, good opportunity to clean these. There should be nothing holding the rack to the underside of the table. The thing I used last time to lift the table was this fairly massive ring, and this actually came off of the Skinner steam engine. It is an anti-rotation ring for the spring adjustment. So I got to figure out exactly how to get the center of gravity of this. I believe it was like this. Got to drop a washer on there first. Using the half-ton hoist. Wanting to come forward just a bit, so let's see if we can get this adjusted a little bit forward. Now the ways are actually recessed under this edge, so I don't have to worry about setting it down on the edges of the barrel. You can see the hold down arrangement at each end here. Let me engage this pinion. These trap the back side of the rack. The rack is bolted to the underside of the table, and the ball cages float back and forth on the VU-ways. Now this is the way that has to have the shim added to it to bring that rail up. I went with 9 thousandths. You know, my number was about 8.5 thousandths in the 6 inches of travel here, and I figured if that's the way it's wearing, I'll go for just a little bit high, and it will, you know, it'll come down and it'll be more in spec as it wears. Yeah, 6-inch centers on the ball races. I'm going to get things wiped down a bit and cover this up until I'm ready to add the shim. It's kind of like a tarry residue. Might almost need something more like lacquer thinner to get some of this off. It's a pretty good shot of how everything is set up. Now, I don't know if you can see over here. Let me run this more into view. This rack is for moving the table back and forth by hand, or when you disengage, you know, all of your pinions, you pull these other pinions back. You know, you can just push the table back and forth without the assistance of the racks at all. It's held in with 1, 2, 3, 4, 5 3/8 cap screws. Why in the world does it have to have a 3/8 dowel taper pin holding it to the casting? You know, to me, if I was engineering this machine today, yeah, taper pins are great for precisely locating something, but that end isn't precisely located. This end is. I would just hold it in place with the 5 cap screws and call it a day. You know, to me, that'd be good enough. So that's just my 2 cents. I don't really feel like disturbing my balls, so I think I'm going to make the shim for the underside of the table. Just wanted to check and see something. This way is 33 1/4. Let's get the rolling table flipped over and have a look at that. Not light, not light. Now these are a little longer. These are 34 3/4. I think the reason why they're longer is because, like I said, there are stops in either direction and the ball cages run up against cap screws, but then you can push the table further. You can slide the table far enough so that at the end of it, this will expose the hold down pieces for the ways. So let's get this wiped down a bit and then remove these cap screws. Those look like 1/4-20s. This is the machined raised surface that the rack bolts to, and it is narrower than the rack so that those hold down clamps can reach under it and grab the edges of the rack. Get the fluff off of that in a minute. Yeah, I don't suppose that rack's just going to lift out of there, do you? We'd be lucky if it even moves. Yeah, I got a piece of aluminum here. I'm going to give it a little bit of a wrap from the end and see if it moves. It is moving. So it's very nicely fitted, but not excessively tight. So now, question is, can I get something under the end of it? That was easier than I expected. There we go. Okay, so we have an overall length of 34 3/4, and we have holes on 4-inch centers. No, they're not. They're not 4-inch centers. Well, that's interesting. So 32 1/2. 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces over 32 1/2 inches. What does that work out to be? 4 1/16 centers. Oh, now there's a perfect example of what the hell was the engineer thinking? Why not 4-inch centers? 4 1/16 inch centers make my job difficult. And I guess no more difficult than 4-inch centers. Just lay it out at 4 1/16. I want to make sure I don't flip this thing end for end, but I do want to clean it up good. I'm probably going to have to resort to a little bit more aggressive cleaner. Definitely shows signs of being bolted down for 70 years. Oh yeah, what's the width of this? It's 1 1/8 wide. So we'll cut our shim at 1 inch, and that way we won't have to worry about it pinching. I have some 9/1000 shim stock here from McMaster. Comes with a certificate that says it's 9,000 shim stock in brass. These mics are reading 4/10 high. I'm just curious. I want to make sure they sent me the right thing. Yeah, it's measuring about 9.7 thousandths, so maybe it's running a couple tenths high. 9.7. I've got a paper cutter, an old one, but this might be as good as anything to cut me the 1 inch wide strips. Interesting, this edge does not register as square relative to the paper cutter. Probably would be a good idea to check to see if the paper cutter is square. Yeah. Oh, that's right. I forgot. When you got the blade down, because there's a camber in it, it'll contact up here. The edge, the cut edge, is square to the scale. So I'm going to try this first. Cut off, I need a total of 5 1 inch wide strips. Then we can lay them out end to end with a little bit of a gap and put the hole pattern in. We'll just have to keep them in order then. Didn't do a very good job at hitting one of the marks there. And let's see how this does. I think that'll do. Got a little bit of a raised edge here. No problem, we can take care of that. So just knock off 4 more. For me to get this, the reverse bend comes out pretty easily. Just trying to get them to lay a little flatter. First hole is at 1 1/8 Okay, I've got the divider set, large pair of vintage divider set for 4 1/16. The gaps aren't critical. I have a feeling one of these is going to land very close or right on my split. So far, so good. Okay, I have my numbered shim pieces with me, and I've got the holes punched. They are 1/16 over size. Looking good so far. All I have to do is put them in order, double checking for burrs as I go. And they should automatically have about a 1/8 inch gap between them. And ready to put it back. Before I do, I want to give one last quick blow of air from the top on these holes. Just cleaning up a few last little pitchy places on the rack. Actually a burr on that end. I'm going to have to sight down these two holes and make sure that the dowel and the final cap screw are going to line up. I don't know if you can see that or not, but that is where I believe the taper pin will pull the rack into proper alignment. Yeah, that is started, but I do have to have it pulled up against the underside of the table with the socket head cap screws before I drive that home. So I'm just running these in until they're finger tight. That way when I tap that taper pin down, it will allow the rack to slide to the position that it was. Like I said, I have no idea why they have to locate the rack with a taper pin to begin with. I would think that the actual socket head cap screws themselves would do a good enough job. Well, there is not a lot of side clearance on that rack because it was dragging on the little clamps. That one's dragging a little bit there. As I get near this end, tightening it up makes it drag. Oh, you know what? I lifted the table and the rack went with it. That's why it's draggy. You know what I'm going to have to do? I'm going to have to loosen these, and I'm going to have to leave them loose for the time being, because what I'm going to have to do now is I'm going to have to shim under the little clamps in order to allow a little bit more clearance to the underside of the rack. Yep, that's what happened, because now it's free as anything up here. So when you shim under the way, I guess I should have shimmed under the bottom table. So let that be a lesson to you guys. If you're going to do this, shim under the table way, and then, will that make a difference? You know, I don't know if that'll make a difference. I'm going to have to think about that one, because I guess anything that you do that's going to push the table away is going to make the clearance to the underside of those little hold down clamps be more critical. Okay, moment of truth, and this is unedited. I have to lift my indicator up a bit more. All right, we are on 0. And I ran it the wrong way. On 0. And we've got 5 in the other direction. Well, there you have it. That is an overshoot of 5 thousandths from, we went from 8.5 in one direction to 5 in the other direction. We moved it 9, 12, 13 and some thousandths with a 9 thousandth shim. I think I know what might have happened. Okay, so we got 2 balls. We got V-way, V-way, and then on this side, 6 inches away, V-way, and flat way. This is measuring 8 thousandths low, so we add, 9 thousandths low, so we add the shim. But what that did on a very, very small scale is it effectively changed the center distance between that point where this ball rides, let's draw a line from there, and this surface where this ball rides. So if we zoom in on this, you know, the underside of that way had, you know, a little bit of a scallop in it, a little bit of wear. And when we change the center distance, one ball to the other, now this ball is no longer riding in that same center. It's riding more up on this edge like this. Well, it's not a very round ball, but you get the point. So it moved differently than what we expected, or there was that factoring into the result. What I'm going to have to do is go back to, I'm going to have to do some ratios and probably take the 9 thousandth shim out and go with something like a 6 or so. And then that'll reduce the error between these two and hopefully bring this back into dead level, although I think we're going to have a little bit of this point contact going on, in which case that's going to wear quickly, so it's going to start to, you know, droop again. Of course, I don't know, it was this side that drooped. I don't know, it's just an interesting phenomenon, because I thought it would have been very straightforward. You know, you read 9 thousandths low, you add 9 thousandths shim, you're good to go. But you are affecting the center to center distance measured from one to the other on a diagonal. When you push this straight down, it becomes a little triangle. So think about that, and I'll let you know what my next move is going to be. So hope you enjoyed that. It's better than it was, but I got error in the opposite direction now, so I'm probably going to not going to live with it. I'm going to try to correct that at some point in the future after I think about it a bit. Sorry, I lost a day on the reassembly of this because I was unloading something. I'm not going to tell you what that is, but you'll see that next week. So thanks again for watching and subscribing, Engineers Workshop. The likes and share them with your friends. That helps with the algorithm. I want to grow the channel, and appreciate all the new subscribers that I've seen in the last couple weeks. So thanks again for watching. Until next time, as always, from Engineers Workshop, stay safe.